Good afternoon. Welcome to today's webinar, everyone, on upgrading legacy RTUs. Presenting the webinar today is Ari Baum, Sales Director for Minsait ACS. Ari's been with Minsait ACS since 2000. Prior to joining Minsait ACS, he worked for FPL as an electrical engineer and later became a chief electrical engineer for the largest privately owned sugar mill and refinery. Ari's also worked for ABB in a sales capacity. His focus is on mission-critical energy and information management systems with special emphasis on substations and distribution grid automation and enabling grid resiliency and reliability. Joining Ari today for the Q&A portion is Joe Boyke. Joe's been with Minsait ACS since 1996 and is currently the R&D hardware manager and lead engineer. Just a few housekeeping items before we jump in today. With the increase of Zoom users and everyone working from home, there could be some technical challenges, so please bear with us if that happens. We'll work to resolve any issues we come across as quickly as possible. This webinar is being recorded, so all participants are on mute, and the chat for this webinar is disabled. We hope to give you a good 30-minute overview, which should allow plenty of time for questions at the end. So if you do have any questions, please use the Q&A button at the bottom of your screen, and we'll do the best to get to those at the end of the presentation. With that, I'm going to turn it over to Ari. Ari, take it away.
Thank you very much, Elena, and thank you attendees for taking the time to join us today in this RTU upgrade webinar, in which we will share, present, and discuss our RTU upgrade solutions. To start, allow me to raise 3 questions. 1, why upgrade an existing RTU? 2, why upgrade RTUs rather than replace one outright? And number 3, last but not least, what has Minsait ACS to offer in the space of upgrading RTUs? Addressing the first question, why upgrade an RTU? Our response is to economically and effectively facilitate grid modernization as related to RTUs. Next is to address other challenges such as equipment obsolescence, the need to improve performance, the lack of spare parts and support, the need to comply with cybersecurity requirements, and last but not least, addressing the reality in which many of the RTU experts who installed and maintained these legacy and aging RTUs have retired. Next, we will be addressing our unique RTU upgrades versus replacement outright solution. We will then share several case studies emphasizing our value proposition. Life extension and migration strategy, the header at this slide, is all about effectively preserving the investment in existing installed base RTUs. Let's get started. Quickly reviewing the agenda, tell you a little bit who we are, talk about the Minsait ACS RTUs, share some of our customers in the space of IOUs, government units, co-ops, and international. RTU upgrades, a large portfolio that we'll be sharing with you, features. We'll focus also on the GED20 upgrades, share some case studies, and then allow for question and answer. ACS was founded in 1975. In 2018, September of 2018, we became part of the Indra Sistemas family. Indra is based in Madrid, Spain. Hence, 45 years serving electrical utilities, mission-critical needs and requirements. We are based in Atlanta, Georgia. We have been smart grid leaders in areas such as DMS, OMS, SCADA, digital solutions, and of course, RTUs. To date, we already delivered, since 1975, over 25,000 RTUs. Many of them are still in operation and use throughout the industry. Over the past 18 years, we've been upgrading second source RTUs, hence non-Minsait ACS RTUs. Before going through the short list below, I also want to emphasize that all along, we've been continuously offering upgrade solutions to our own aging Minsait ACS RTUs. The list below addresses some of the RTUs that we have very effective upgrade solutions for. Like to categorize or use 2 categories. One referred to as the centralized architecture and the other one, the distributed architecture. In the obsolete centralized architecture, you can see RTU manufacturers such as Landsengir, Harris, System Northwest, Litton Northrop, and Tejas. Those companies do not are no longer in existence. In other words, the RTUs are there, they still perform, they still operate and do their functions, but they are no longer supported. Many of the companies have gone and no longer exist, some other were absorbed, etc. Below, underneath the obsolete centralized, are the aging distributed architecture. Those are the GE D20s and the Telegear 5700, for which we also have upgrade solutions. Just to share quickly, and later on we'll address it more, to date we delivered over 3,000 peripherals as far as the GE D20 upgrade solution, and over 700 peripherals on the Telegear 5700. This slide shows some of our RTUs. Top left is our very small guy called the NTX20. We like to affectionately refer to it as an RTU on steroids. On the right side are the various NTX 200, 220, 240, 260. And basically what we present here is a scalable solution from small point counts to very, very large. And really there is no limit to how many points, discrete and or virtual, we can accommodate those RTUs. To the left bottom, we address the second source RTU upgrades. And just to let you know that in the upgrades, we also use our own RTUs that we show on the right-hand side. Addressing the market that we are actually performing and servicing. Here are examples of IOUs, co-ops, government agencies, federal utilities, and so on and so forth. Quite a very impressive list of utilities. Needless to say, we couldn't put all of them here, but we have a few here that you can see who are some of our customers in the upgrade and RTU space. Addressing a little bit the concept of upgrade versus replacing. Why upgrade? And that right away puts us into the value proposition discussion. First and foremost is cost reduction when upgrading versus replacing. And we have quantifiable evidence and references that we can reduce the cost of an upgrade versus a replacement by a factor of 2/3. Next is significantly reduce installation commissioning time. And that is another extremely valuable aspect and hence value proposition. Last but not least, we reduce risks. And I'm showing a picture on the right side there where we see many wires hanging off some of the peripherals. And the nice thing is that in our upgrade solution, and you'll hear it again later on, we don't touch any of the wires. Hence, we reduce risks in that process. What is an upgrade? Just in general, and also a little bit more specific. In the upgrade process, we replace the RTU logic, control cards, processor, etc. We also replace the old power supply. On the other hand, we retain the control relays and associated wiring. We retain the existing digital and analog input termination modules. In addition, we retain the existing field wires that are not being attached. And most and foremost, nothing has to be changed up at the master level. The master database and displays are untouched in the process of upgrading the RTUs. Mentioned earlier that we have a very large portfolio of legacy RTUs that we upgrade, 27 of those if you count them. You can see that we start on the left top with the Landbased gear with different models. And if you go down, you see the System Northwest, the Little Northrop, and yes, believe it or not, but Chrysler, the very car companies that we still know today, Chrysler, Fiat, but then before the Fiat days, they also manufactured RTUs. And yes, we upgrade those as well. 40 years in existence, maybe longer. On the right side, we show some more of the list of upgrades. And on the bottom of the right side, we show the D20 upgrade and the associated customers that we brought on board in the last 6 years since we basically released that solution of upgrading the GD20 RTUs. What's so unique about the GD20 RTUs that we just mentioned? First and foremost, we facilitate upgrade in which no backplanes nor the term modules that accommodate the field wires are touched and the wires are not removed from those term modules. We provide field-proven experience in excess of 6 years now, and with over 3,000 of peripherals sold and to a great extent already installed in many substations. Each of these modules that I'll be showing you in a moment also performs as an IED. It is an RTU, each of those peripherals. If desired, they can perform as COM processor data concentrators. In addition, they are also capable of integrating IEDs. Now, typically we will upgrade the RTUs, but if a customer needs to replace the term module or wants to expand further, we also offer term backplanes made by Minsait ACS. Another unique feature is that on a digital inputs, we have timestamping at 1 millisecond using either IRB or GPS. The control module, the U20K, can handle up to 256 relays. Similarly, the U20C, the combo unit, can handle up to 32 units, relays, and also includes logic application capabilities using isograph, adhering to the IEC 61131 standard, and we internally refer to it as the NTX logic. We also natively make available a Radius client for remote authentication. All design, development, and manufacturing of the NTX U20 and all of our solutions, in fact, are done in the US. Other features that are common to our solutions: the operating system is Linux. The communication protocols we offer are DNP, Modbus, and IEC 104 over IP. The communication media are both copper and fiber. All the electronics that are being used are off the shelf and current. We adhere to cybersecurity requirements and we comply with NERC requirements. If needed, we offer conformal coding and we offer a 10-year warranty. This is a longer list of features benefits. I will only address a few. So you will see when I show you later on the images that we have on board a dual port Ethernet switch that allows you to communicate between the modules and to the host RTU as well. Keep it on for another few seconds, just for a glance. And go to the next slide. On the left side, you see a typical GE D20 peripheral. It contains or consists of a term module, a middle section that's called the WESDAC, and a plexiglass acrylic display cover. On the right hand is an example of one of our peripherals, happened to be a D. Please note that the term module happened to be a GE Westerm, and we just mounted our WESDAC on top of it. In other words, we do replace the WESDAC, but we do not touch the Westerm. The Westerm with all the field wiring remains intact in place. Here are the 4 typical modules that we have available for upgrading GE D20 existing peripherals: the analog, the status, the control, and the combo. You can see up front the dual port switch, and later on you'll see how it's being used. As mentioned, not only that we offer peripherals, the DACs, but also the Westerms. For each and every one of the modules, we also offer a Westerm, so that here are some of the options. Needless to say that for an upgrade only, one would use a WESDAC, but for expansion, replacement, in case of a brownfield environment, one would use the Westerm and WESDAC. And yes, we do have customers that even for greenfield application use our solution, and in that case, they would use both the Westerm and WESDAC. In addition to the copper, as mentioned earlier, we also offer fiber solutions. So the media here is fiber. If you look at the top and the bottom, right side modules, both are the Ds. The West DAC portion is alike, identical. What differs is, of course, the West term, and it's a good opportunity to see that we offer both the DB25 and the compression terminal capabilities. The image on the left side shows an application whereby on occasion we find that the existing installed peripherals are mounted in an enclosure, and the door, or the cabinet door, is very tight to the RTU, to the peripheral. And you can see here how the fiber can be basically bent almost 90 degrees and can perform and work within a very tight environment such as the one depicted in this picture. In this slide, we are showing the left side, the fiber, the right side, the copper, and you can see how the communication between the peripherals is done in a daisy chain type manner. It always goes from one of the ports to the next and the next and next and so on, and ultimately it will, see it shortly in the system architecture, wind up in a host RTU. And this is exactly what I was just referring to. System architecture, you see on top, we have a host RTU. In this particular case, it's one of our NTX series, the one I showed you earlier. And below it are the peripherals. I'm showing one of each, just for example. We have cases where there's only one peripheral in the substation, or there are many. I've seen substations that had 30, 40 peripherals in the substation as well. They communicate between them, as you can see, through, in this particular case, we are dealing with the copper and the daisy chained copper-wise. We are interfacing through an Ethernet LAN to the host RTU. Notice that this particular peripherals show that we can integrate the IEDs as well. So those are, as I mentioned earlier, each and every one of them is an RTU, and as such, it can communicate and also integrate IEDs. Just the FYI, of course, every one of those modules has its own IP address, given that those are IP devices. The next slide shows a slight difference. The only difference here is the host RTU. We like to use the word agnostic. We are totally agnostic to whose RTU the customer would prefer to use. And many of our customers use our RTUs, but many others use somebody else's RTU. As long as the RTU communicates DNP IP, they can then connect to our peripherals and they're good to go. So here again, a daisy chain between the peripherals and linked through a LAN, Ethernet LAN, to the host computer, or the host RTU that in turn then communicates to the DMS, EMS masters. The next slide shows a slightly different topology whereby the customer uses a star configuration. Rather than have them all daisy chained, they can all go into a switch, and then on the switch can then go to the host RTU of choice. Other than that, everything else is alike. This last topology is rather interesting because, once again, because each and every one of those peripherals is actually an RTU. In certain conditions, when you don't have a lot of data, or if you don't wish to invest in a host RTU, the peripheral itself can perform as an RTU. It is rather important to emphasize that each and every one of them can perform as a data concentrator. In this particular example, we're using the D as the data concentrator. So you can see that the K, the C, the A are all daisy chained to the D, and then the D is going directly up to the master through a switch or a modem, not using a host RTU. So that's yet another nice feature that we offer in addition to all the many that already mentioned earlier. Remember, I said that we'll get back to the value proposition and demonstrate and show some of the case studies that we encounter with our customers. So just quickly reminding everybody that our value proposition is a factor of 3. First, cost reduction. 2, time reduction, and risk. Everything we reduce here through our upgrade solution. Here's an example of one of the early installations, one of the electrical utilities that we service. Left picture shows what we found when we got there. Right side is, of course, the upgrade, and that all took place in less than a day. You have 5 peripherals there, and you can see the dark ones on the left side are the GEs, the right one are the ACSs. And yes, we are using a third-party RTU as a host RTU in this particular case. This was another successful situation where we demonstrated cost saving and time reduction. In one day, we basically upgraded a relatively large RTU system that consisted of 16 peripherals. And in less than a day, we were able to upgrade this substation to the utmost satisfaction of the customer. Again, time and cost savings to the max. Here's an example where risk reduction can come into play. This particular installation shows a case whereby the RTU peripherals are basically flushed to the wall. And again, without having to touch any of the filled wires. They just removed the top part that was back. And on the right side, you can see within a few hours, less than a day, they were able to upgrade this substation from the old existing installation to the new one. The last one here is not a nice picture as the previous ones, but I'm trying to show a little bit on occasion in which environments we have to operate. So all those yellow wires have nothing to do with us. The cabinet next to the one with the yellow wires is where we actually went in. And if you look in the center picture, I'll hover my mouse around it, you can see the number of wires that are hanging below on this term module. Again, if somebody had to replace all of this, the risk associated with it would have been tremendous. By not having to touch any of the wires, by simply removing the West backs and coming and putting ours on, in a day again, this substation was retrofitted. And that's it for the time being. Question answers. Thank you.
Joe, I've got one if you want to kick things off while Ari has a chance to review the questions that have come in. How difficult is it to configure the NTX U20?
Sure. It's actually very simple. I demonstrated it last night for a customer in under 60 seconds. Went from no configuration at all to having the configuration downloaded, and the unit was in the process of rebooting and coming back up. There's only 3 steps you really need to do. Set your IP address, set your DNP or whichever protocol address and port, and hit the download button, and you're done. Now, certainly you can go in and do additional changes and tweaks to it, but to get a minimal, as fast and up running as you need, it can literally be under a minute. But we also have features to allow you to rename ports, define, move points around, any number of additional things you can do that obviously take a little more time, but the basic can be very fast.
Thanks, Joe. Ari, are you able to see the questions?
Yes, I see questions, and there are still a good question for Joe to respond. I see several questions here in the space of IC 61850. And Joe, if you would like to address some questions. Right. When does ACS intend to offer IC 61850 protocols?
Yeah, that's something we're working on currently. Our parent Indra Minsait company has a 61850 implementation, And obviously, we don't want to reinvent the wheel with doing it ourselves. There's quite a bit of work involved in implementing that protocol. So we are working on how we can integrate their solution into our RTU. And we're expecting to have something this year that will be able to address that. Assuming we're not all stranded at home for the remainder of the year with the COVID virus. It makes it a little more difficult to work on these things, but that's the goal right now.
Joe, more question in your direction. So I'll help you because while you answer, you cannot read.
Sure.
The question here is, what are our plans to equip our other RTUs, not necessarily the U20 and U57s, the other RTUs with fiber ports?
Right. We currently have, as Ari showed in the presentation, the fiber ports on the U20 product, and we've got the same fiber ports available on the U57 upgrades for the Telegear 5700. We are in the process. That's another one of the items we're working on for this year, is to add the fiber port capability into the main the 200 series RTUs. So later this year.
Here the question I would say Joe answered, but I can answer that one too. The question is, does the configuration file can be imported from a flat file or has to be entered manually through the configuration software each point at a time? And the answer is yes, we have a import-export tool available, and that can be accommodated and is being used oftentimes, in our configuration environment. Yes. There's another question here says, do you have an RTU with serial DB9 connection instead of DB25? And to that effect, yes, the NTX20, the small RTU I showed earlier, it has DB9 connections available, and we on our other RTUs can offer a DB9 connection as well.
Okay, and I'll also add in, there may have been a bit of confusion there. And the pictures where Ari showed that the Western modules, GE uses those DB25 connections to bring in the I/O signals. So those are not actually serial ports, those are I/O connections. And GE or Westronics originally chose those because they're ubiquitous nature. And so those are actually not serial ports, but they're I/O'd instead.
Question is, can the RTU configuration be downloaded to a file to be backed up on a server? And again, the answer is yes. We can export the files and we can save the files. So the answer is yes. If you want to elaborate as far as the configuration to be downloaded and backed up on a server.
Yeah, we have the option. It's stored in a binary file format, but certainly it can be retrieved from a unit and written, saved on the PC, and then that can be transferred to a centralized storage.
A question that is a good one to answer. What if we have to replace Western modules? Do you offer such modules? And the answer is yes. We presented in our slides those term modules. We have term modules for every one of the different RTUs or peripherals that GE offers. Yes. How about redundant Ethernet? Redundancy, if you want to address that one, Joe.
That's something we're currently looking into. The switch on the NTX U20s is a 2-port switch. So we're looking at what we can do with that to have it operate in a redundant manner as opposed to a pure switch. We're also looking, it's one of the things we're investigating now is how we could have, for example, 2 gateway cards in a 200 series RTU function as a redundant port. Certainly you can have a virtual device on each card and have it report to separate masters, but to make it fully redundant is something we're still working on.
One of the questions here for you again is which protocol use on LAN to communicate with other NTXU devices in the same substation?
Okay, you have your choice. We support 3 LAN-based protocols. DNP, obviously, the one we've talked about the most here, but we also support Modbus over TCP and IEC 6870-5-104 as well.
I think that's it, guys. Any other questions out there? Go ahead and throw them in the Q&A box now while you've got your chance.
We're always happy to answer more questions as they come along.
You got one more there, Ari.
Let's see if I can see it. How many statuses are able to be stored in the buffer of the NTXU20D if the host is stopped calling it? So I'll let you answer that.
Yes. The hardware buffer on the D itself supports 1,000 changes. Then the software buffer supports, several hundred additional to that. So you've got a pretty substantial buffer there before it overflows.
Got one more that came in.
Okay.
How about the migration of a CDC 44500 RTU? How do you connect the IDOs 45500? Do you need the middle card between them? That's a very good question, and that is a separate upgrade, one of the many different upgrades that we have. Spend a lot of time talking about the GED20 upgrades, but yes, with the 44500, we also have a nice solution. Joe, pay attention. This one says 550, not 500.
Right.
But we've done the 500, I suppose. Right?
We've done the 44500. We have also done some retrofits of 44550s, where the difference that we had to deal with was the fact that the connection for the relays is different between the 44500 and the 44550. And we have an adapter that supports communicating to either of those style relays. I believe that, and I'm not 100% sure, but I believe the DI and AI were the same on those.
We'll be more than happy to share with you details on that upgrade, as we have a very, very happy customer that uses them continuously.
Yes.
Well, if that's the case, then I think that we can thank everybody for taking the time and joining us at this webinar, right?
Yes, thank you, everybody. And be sure to check the events page of our website, acspower.com, where you'll find webinars running all the way through August. So feel free to join us on any of those. Thanks again for joining us. Stay safe and stay healthy. Take care.